cortex, the wrinkled outer layer of the brain, orchestrates talents and skills. It's a network of nerve cells. Music, language, mathematics, problem solving, and face recognition all are activated here among the billions of neuronal connections. The two halves of the brain may look alike, but they're not. They're asymmetrical. They don't have identical skills and abilities. Each side has its own way of knowing the world and processing information. By and large, each side controls the opposite side of the body. When you move your right hand, the left side of the brain is at work. When you move your left hand, the right hemisphere is in control. Most people have a dominant hand, a sign of the brain's asymmetry. Most mental functions, like language and spatial skills, are generally housed in one hemisphere or the other. This division of responsibility makes evolutionary sense. Normally, both sides of the brain work in concert. A massive system of fibers, called the corpus callosum, carries impulses to and from each side.
Have a silver clip ready, please.
In the early 1960s, surgeons revived an old technique of cutting the corpus callosum to control massive seizures in some epileptics. The operation works. It also provides an opportunity to study the different properties of the two hemispheres.
Right hemisphere is gently moved away from the midline.
Vicky is a split brain patient. Because of her epilepsy, surgeons severed her corpus callosum. But now her right hemisphere can no longer communicate directly with her left.
I knew what I wanted to wear, and I would open up my closet, get ready to take it out. My other hand would just take control. It would reach in and get something that I wouldn't want at all. You know, and then I get, I don't know, frustrated, and I throw the one on the bed that I don't want. Instead of, a lot of times I can't even hang them back up.
This antagonistic behavior between hands occurs only right after split brain surgery. It takes special testing to reveal the different processing styles of the two hemispheres. Vicky is tested frequently at Cornell Medical Center by Dr. Michael Gazzaniga.
Okay, look right at the dot.
Okay.
The tests are designed to send different kinds of information to each hemisphere.
I simply want you to describe them to me. Just name the picture you see.
Okay.
Okay?
All right.
So get ready and look right at the dot. Fixate the dot. Look right at the dot.
Football. Shoe. A woman. A person.
What else?
A girl, that's all.
Okay, I tell you what. Open your eyes. Your left hand. Right what she was doing. Close your eyes and just let your left hand go.
Vicky's right hemisphere doesn't have the language to describe the whole picture, but it can express itself through her left hand.
Good. What did you write?
Skipping rope.
Huh?
Skipping rope.
Skipping rope? Let me show you what you wrote there.
Telephone.
Yeah, what was she doing?
Talking on the telephone.
Remember that?
Yeah.
Good. Perfect.
Vicky saw the picture on her left. It went to the left side of both eyes. The visual information then traveled to her right hemisphere. It understood the picture, but could only say, woman. Then she was instructed to write using her left hand. Her right hemisphere directed her hand to spell out the other feature of the picture. Dr. Gazaniga asked what she had written. The left hemisphere tried to guess. It had not seen telephone, so it searched for a word somehow associated with the image it had seen. When both hemispheres saw the written word, the left, which had heard the right say woman, could now give a complete description. Woman on the phone.
In Vicky, we are able to test the separate functioning of each hemisphere by the special kind of lateralized testing that you saw. In particular, in the case where we present visual information in her right visual field, which is over here, that information is projected in her left hemisphere, which is the normally dominant language and speech system in you and me as it is in Vicky. That means if I flash a letter over here, she can normally name it, a picture, or anything else. However, when you flash the same kind of information in the left visual field, which goes to the right hemisphere, you find that Vicky is not able to easily name it because of this structure having been sectioned. The communication between the two half brains has been eliminated. How about another one here? You're doing just perfect. Oh, this is a good one.
I don't know how.
Both hemispheres respond to the words. The left triggers her smile, the right makes her clap.
So what did you see that time?
Both sides receive the command at the same time, but the left side can communicate its awareness.